This is a quick demonstration of a joint VMware, Cisco, and EMC joint validation exercise focused on long-distance vMotion use cases. This can be used either for disaster avoidance or for data center load balancing. The testing included a variety of options ranging from freely available capabilities natively within VMware, ranging through active-active storage virtualization models. The testing was done across a wide set of latencies representing various distances, up to a maximum tested of 200 kilometers. First, let's start a workload in the VM that will be vMotioned. In this case, we're using a common SQL Server OLTP type benchmark. We've also got a WAN simulator between the two vSphere clusters. While the testing was across a wide range of latencies, in this demonstration we'll just use the maximum that was tested, which was roughly 200 kilometers. You can see here that with a quick ping between the two servers at the primary and secondary site, currently in effect they're local to one another with latencies that are a millisecond or less. Now, going to our latency simulator, we'll increase that latency to represent a round-trip latency that corresponds with 200 kilometers. This latency simulator can also insert errors and other things that simulate a real-world wide area network condition. You can see here that the true delay now is a one-way 2.3 milliseconds. And in effect, this translates to just under 5 milliseconds round-trip latency. And if we go and we take a look, you can see that latency is actually represented here between the two ESX clusters. Now we'll undertake a series of actions to test the behavior of moving the VM from one site to another. In the first case, we won't move the storage. We'll simply use a stretched SAN or a stretched NAS environment coupled with vMotioning across a long distance. So, triggering the vMotion operation, you'll notice that we're using vSphere 4, which has fairly significant vMotion inherent improvements over Virtual Infrastructure 3. We're going to trigger the vMotion, and off it will go. Now, the challenge with this approach is that the storage remains on the original side. However, the operation occurs relatively quickly. So you can see that the long-distance vMotion over 200 kilometers under that workload only took 1 minute and 38 seconds. The next test was to determine the effect of doing a storage vMotion operation across the same long distance. This could be coupled with the first step to actually bring not only the VM execution from one cluster to another, but the storage along with it. Now, obviously, in this case, the LUNs, if you're using VMFS, or the NFS data stores must be visible to both sides. This will reduce the effective number of data stores that you can use. However, in many cases, most customers are below the cluster limits for maximum number of LUNs and maximum number of NFS data stores. Now, you'll notice here that we're moving from the primary data store to the secondary site. Now, vSphere 4 has got some significant storage vMotion improvements. There's a GUI that we're obviously using here. You can use any source and destination protocol, so you can move from block to NAS and vice versa. You can also change virtual disk types, as you can see here. There's also significant under-the-hood improvements around performance and reliability of storage vMotion. But remember, here we're moving between one site and another across a long distance. So storage vMotion will take roughly around 4 times longer at this latency than it would normally. So here you can see the storage vMotion under load over that distance took roughly 15 minutes and 26 seconds with that particular VM. The next test is an interesting variation, one that leverages technology coming from EMC around active-active storage virtualization across distance. Using this technology, each one of the two vSphere clusters to each other seem like they're accessing the same storage, even though it's stored on totally different storage arrays on either side. This means that you can simply do a long-distance vMotion, as opposed to doing a storage vMotion coupled with a long-distance vMotion. And if you see here, this operation takes the same amount of time as it took in the first place just for a long-distance vMotion, about 1 minute and 39 seconds. So as you can see here, there are many options ranging from those that you can do with any sort of stretched SAN, NAS, and stretched LAN infrastructure using long-distance vMotion and storage vMotion, and as well these sophisticated active-active storage virtualization technologies coming from EMC.